Hi guys, this is Vijay. Welcome back to my YouTube channel. Uh, in previous video, we have seen this self-attention mechanism in transformer architecture. This self-attention mechanism is most popular in nowadays large language models such as ChatGPT, Google Gemini. So these are used. These are the basic self-attention is the basic mechanism in these popular language models. So this we will visualize this attention score in uh, our Google Colab by writing Python code. So let's go to Google Colab and try to understand the existing code. So first I will import NumPy array. This is used to deal with the vectors available in our data, and the next two libraries are visualization libraries which are used to plot the heat map. There are in this visualization process I have created three functions, namely first one softmax function, which is an activation function generally used in neural networks, and also it is also used in attention mechanism to create a probability array that has the values in the range of 0 to 1, and if we sum up all those values it will give you a number called 1. So this is our first function that is defined in our code. And the second function is scaled dot product attention function. This will give you attention weight, and this is the heart of self-attention mechanism that will give you the context of each word with other word in the sentence. So this is the main dot product, or this is the main equation that we have implemented using this function that we have seen. Next is mock embeddings. This is a function used to create a vector representation of a word. If you have some word like tired, it will be represented in a numerical vector format using this function. So this is our one of the function. And lastly, to visualize all these values in a heat map, we have written this plot attention heat map function. Let's go through quickly all these functions, how it has implemented. So softmax function has some formula. Just I will give you an idea of on a paper. So if you have some elements, n elements in an array like this, 0.1, 0.3 and so on, some n elements in an array. So how you will implement softmax of this array or vector is e to the power xi divided by sum of e to the power xi. Here I ranges from 0 to n. So this is how you will calculate the probability vectors of the array vector array available. So that's what here we have implemented. And next is scale dot product attention. As we said, here you can see how it works. Means Q is what I am looking for. So here we are looking for the word called it and the relationship with it to animal. In this sentence we have shown in the video. So next is key is what do I have. What do I have is all the words in the sentence. Those are called keys. And the value is the information we want to retrieve from that word, right? Then we will calculate the attention score using the formula, and then mask diagonal. Here you can see this is number of dimensions, attention score, masking the diagonal. This masking diagonal process is used because to calculate attention score of a word with another word, but not with its own word. If you doesn't mask this diagonal with a negative value, it will give you a number highest score with its own word. So that's why we are going to mask a diagonal in the matrix. Then you calculate attention weights, and then you multiply it with the value vectors and return those two attention weights and the output. This is how scale dot product attention function is implemented. And let's see create mock embeddings. This is how a word is converted into numerical representation. This is only for the sentence we have hard coded. So this takes the words as strings, and let's assume the number of dimensions in this vector are 64. Let's assume number of dimensions as 64, and for each word I am going to create a random array with some random numbers initially. Then to amplify the value of the feature embedding word, initially I have created some values, right? To amplify the signal, we are multiplying it with the number 5. Then I am here, you can see the context feature which has amplified is added to the word it and animal, as we are trying to find out the relationship between these two words. And we know that it is not going to be related to street. So that's why we are subtracting the context feature calculated above from this embeddings vector and returning all the embeddings as an array, right? Then this is the process, this is the function for plotting the heat map. So I will give you a quick walkthrough on this. First, the complete sentence is converted into a list format. Then a figure is plotted of size 12 by 10. The heat map takes the all attention weights, and each label is the words available in the, you can see highlighted with the sentence words in X axis, and this is Y axis labels, and this is color format, and this is annotation to visualize the numbers, and this is decimal places to visualize and do the square of that value and label that as attention score. This is total plot title, x-axis label, y-axis label, and we are going to print attention score for it versus animal in 2 decimal up to precision of 2 decimal, and also we are going to plot print the value of it versus street attention score here, similarly with the tired. So let's run these 3 functions first. I will run from the starting using shift enter. So till here I am going to define all the functions. Right, here is the main execution. We have defined the main sentence that we are going to consider for this video. Then first split that into list and initialize the dimensions. As we created the function, we have passed all the words as a list to this function create mock embeddings, and number of dimensions. This will calculate the embedding values. That means the word is converted into 64 numerical value vector dimensions. We have initiated this q, k, v values. Then attention weights and output is calculated using scale dot product function. This will take q, k, v and mask diagonal. Then visualizing the heat map. You can see here it and animal has highest score 1, and the other two are having 0 value, which means those are not related with each other. As we have tuned that sentence here, as we have tuned, you can see as we have tuned it over here for having a strong relationship with it and animal. Right, so this is the heat map. You can see one problem in this heat map. Street and tired are having a strong relationship as the score is highest 0.95. Streets won't get tired as they are concrete material, right? This is one of the problem in AI. This is called as hallucination. This can be treated using backpropagation while training. So I think you understood some self-attention mechanism. I will put this code in my website. You can take it from there for free and download all the code. So that's it for this video, guys. I hope you like this video, and I will see you in the next one. Thank you.